Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about the further statistics, paper 4, May June 2024, paper 41. Let's take a look at the question number 1. The times taken for the members of a large cycling club to complete the cross-country circuit have normal distributions with the mean mu minutes, and the time taken x minutes are recorded for a random sample of 14 members of club. The results are summarized as follows, where the bar x is the sample mean. Okay, these are the value given. Then they want you to find the 95% confidence interval for the mu. Okay, so first of all, we need to find the unbiased estimations of the population variance. That will be S squared equals to the sum of the x minus about x squared divided by the n minus 1. So since the result already given is a 941.5 divided by 13, press a calculator, then you will get the answer as 72.423. So I will give my answer in 5 significant figure. Then after that, I want to find critical value. So this critical value, we will be using T distribution because this one, the sample size is less than 30, so it's considered as small. So this one is degree of freedom, 13, and the confidence level is 95%. So since it's two-tailed, so we need to make it become 97.5%. Just check from the formula table. You get this answer as, you will get this value as 2.160. So now we are ready to find the 95% of the CI for the mu. That will be 42.8 plus minus the 2.160, the critical value, and the square root of the S square, 72.423 divided by n. Your n is a 14. So we just use this formula. Then press a calculator directly. The smaller value here will be 37.9, and the larger value here will be 47.7, including 37.9 and including 47.7. So that will be the answer for the question number 1. Okay, so now we're moving on. Question number 2. Okay, now we take a look at question number 2. A large number of students are taking physics course. They are assessed by practical exam, okay, practical exam, and the written exam. So we have 2 types of exam over here. The mark out of 100 by a random sample of 15 students in each of the examinations follows. So student A until O, okay, A until O, you have 15 of them, and they both taking practical and written exam. Use a sign test at 10% significant level to test whether on average, the practical exam marks are higher than the written exam marks. Okay, so over here, we just need to let P equal to the practical exam mark. And the W as the written exam mark. Okay, and we let the D, we are suspecting that the practical exam marks is higher than the written exam mark. So the P minus the W, or you can say that the P greater than W. P greater than W, in other words, means that the P minus the W will be positive. Okay, since we are looking for sign test, we will just let the D is equals to the P minus the W. So we will build another small table over here. So this is the student. This is the D equal to P minus W. We have student A, B, C, D, E, F, G, H I, oh, so many. Okay. J K L M N O P N O J L M N. I think not enough place. Okay, so maybe I just make use of the table above. Just make use of the table above to find the sign. That will be easier for me. Okay. So I put the D here is equal to P minus a W. So just take the P minus W. You get a positive, positive, negative, and positive, 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 and also positive. This one is negative. This one is negative, negative. So you have a positive, 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 and positive, negative. Okay. So the number of positive sign and the number of negative sign. Okay. So we want to check the number of positive sign and the number of negative sign. How many of them? We need to count. So the number of positive sign is 10. So this one, it will be 5. Okay, so this is what we have. Now we are ready to do the hypothesis test. So first of all, your null hypothesis and your alternative hypothesis. We are considering that overall, on average, the practical exam mark are higher. Okay, the practical, that means the median. Okay, the median of the practical mark is equal to the median of the written exam mark, or the median of the practical mark is higher than the median of the written exam mark. So just like that. So this one is a right tail test. Okay, now the alpha given is 0.1, significant level. For sign test, we will use the p-value approach to do the hypothesis test. So first of all, we need to find the binomial distributions. We need to form the binomial distributions. You have 15 of them, and the chances to get positive and negative is equal, half. So we are talking about positive sign. We are talking about the positive sign. It's a 10. Okay, so we just put probability for x greater or equal to 10. Okay, so since that the mean is 15 over 2 is 7.5. So 7.5, the 10, 7.5 is over here, 10 is here, then you have to go to this right-hand side. Okay, so for this case, you need to say x greater or equal to 10. That will be the same as the px equal to the 10, 11, 12, 13, 14, and 15. You have total 6 probability you need to find. But because the P and Q are the same, so actually there's no harm at all. I mean, not very difficult for us to find the probability. Okay, so because the formula for binomial distribution is supposed to be NCR, P power R and the Q power the N minus R. Since the P and Q is the same as a half, okay, since the P and Q as a half, so if you combine them together, then you will get this one as an NCR half power the N. Okay, so that will make our job a lot easier when we want to calculate this probability. So over here, since all the half will be power of N, so the N is a 10, so I just take the half power 10 out. This one will be 10C, 15C10 plus the 15C11 plus the 15C13 plus the 15C14 plus the 15C15. Okay, just like that. Then press the calculator out. Just use the calculator, then you will get this as a 0.151, 3 decimal places. So this will be my p-value. Okay, I compare the p-value with the alpha. So if the p-value and compare with the alpha, p-value is actually greater. So p-value greater means you have a larger area, then means it will be inside the acceptance region. Okay, inside the acceptance region. So over here, we will just say that accept H now. So your conclusion, there is insufficient evidence to support that the MP is greater than the MW. Just like that. So this will be the answer for the question number 2. We take a look at question number 3. The factory produces metal discs. The manager claims that the diameters of these discs have a median of 22.0 millimeter. The diameters in millimeter of a random sample of 12 discs produced by this factory are as follows. So these are the data given. Part A. Carry out a Wilcoxon psi rank test at 10% significant level to test whether there is any evidence against the manager's claim. So to save time, I have drawn the table here earlier. So now what you need to do is to, first of all, we build the hypothesis first. The null hypothesis and the alternative hypothesis is that the manager claims that the population median M is equal to 22.0. Okay, so the alternative hypothesis is that the population median M is not equal to 22.0. So what we need to do is that we need to find the sign because it's a Wilcoxon psi rank test. So we just take x minus a 22.0. Then we just minus it accordingly. So here you get 0.4. Here you get negative 1.1, 0.8, negative 0.5, 1.2, 0.9, 1.9, negative 0.3, negative 2.2, 1.6, 0.6, and 1.0. So we need to calculate the sign that is positive and the sign that is negative from ascending order. So the smallest one will be here, 1. Q representing negative sign, P is representing positive sign. Then we have a 2, we have a 3, and then we have a 4, 5, 6. Then we have 7, 8, 9, 10, 11, and then 12. Okay, so now after that we total up the positive sign and the total up the rank of the positive sign together and the total up the rank for the negative sign together. So over here you get 54 and you get 24. Okay, so now we are ready to do the hypothesis test. The test statistics over here, it will be, you can write over here. We write the critical value first. Okay, the critical values from the table, from the formula booklet MF19. Okay, the critical value from the table, it will be just check from the table. You get this one as a 17 with the significant level 10%. This is a two-tailed test. Okay, this is a two-tailed test. So it's a two-tailed test, 10% significant level. Just check from the table will do. Then your test statistics is actually the minimum between 54 and 24. Okay, so the answer will be 24. Then the test statistics is actually greater than the critical value. So from here, we accept H now. So accept H now, then we can go for conclusion. There is insufficient evidence to against the manager's claim. Manager's claim. Done, just like that. This is the answer for the question number 3, part A. So now we move on to the part B. State an assumption that is necessary to test for this test to be valid. So what is the assumption? Since Wilcoxon is about median, so the assumption is that the distribution will be symmetric about the population median. Okay, so we just say that the assumption will be the population distribution is symmetric. Symmetric is a keyword. Symmetric about the median. Symmetric about population median. Okay, done, just like that. So this is the answer for the number 3B. And moving on, we have question number 4. Okay, now we take a look at the question number 4. The random variable y is a sum of two independent observations of a random variable x. The probability of generating functions of gy is given as the following. They want you to find EY. So to find EY, we need to differentiate this. So this one is a quotient rule, but I do not want to use quotient rule. So I think over here is better. I use it as a product rule. I make it like this. Then I only differentiate. So I'm using product rule. Keep the left, differentiate the right. Plus, keep the right, differentiate the left. Okay, so over here, maybe we can simplify it by taking the, I have a 12t, 12t squared over the 4 minus the 3t power 5, and then plus the 2t over the 4 minus 3t power 4. So actually, is it needed to be simplified? Okay, let's check. I think no need lah. Okay, we just leave it like this. No need to simplify further. Okay, so now to find the EY, just put the G prime 1. Okay, your G prime of the Y, put the 1 inside. So you get a 12 over the 1 plus the 2 over the 1. So you get the answer as 14. Done. That will be the answer for the EY. Now we are moving on for the part B. Write down the expressions for the probability generating functions of X. Okay, the PGF of the X. So since they mentioned that the Y is a sum of two independent observations of X, so we just need to write that the Y is equal to X1 plus X2. Okay, there are two independent variable of x. So your gy is actually gx1 plus x2t. That will be the same as the gxt and then the whole thing square. Okay, but your gy is given as the t square over the 4 minus 3t power 4. So what you need to do, just need to bring the square, go to the other side, square root it, then your gx is actually square root everything. Then you get this. Okay, we will take positive value. Okay, we take positive function. Okay, so this is the answer for the part B. Then now we move on to the part C. They want you to find the probability for x equals to 4. So this one we need to look for the gx. Okay, you need to extend them until t power 4, and you look at the value of the coefficient here. That will be your probability for x equal to 4. So what you need to do now is you just need to take the gx result from the part B. I will write it as the power of -2 here. So this one I need to use binomial expansion. I need to use binomial expansion where the n is a negative value. So this is, you can just check the formula booklet for the binomial expansion. So first of all, I take the 4 out. Make it like this. Then I have t over 16 of 1 minus 3 over 4 t power -2. Then t over 16, use the formula booklet, check the binomial expansion. Then this one, you will get a 1 plus the -2, -3 over 4t. Oh, this one a bit long. Okay. So this one is -2, -3 over 2 factorial, -3 over 4t power 2 plus the -2, -3, and but actually I do not need to list out until t power 1, t power 2. I just need to show until t power 4. Only just need to show the t power 4 will do. Okay. So okay, but never mind. Okay, we just show it since I show it halfway already. So we just show it. So now I'm going for the t power 3. T power 3 will be like this. It's not needed because the question not require. Then the last one will be the t power 4. -5 over 4 factorial, -3 over 4t power 4 plus a dot. Okay, so the expansion is quite long. Then since I need to multiply by t, so actually this one multiply by t power 3, I already get t power 4. Actually, there's no need for me to show until this anymore. This one is not needed. This one is too much already. So we just need to show until here. Plus a dot. Okay, so therefore, your px equal to 4, just look for the 1 over 16. Forget about the t, ignore the t. Multiply by the -2, multiply by this. Okay, this one. Oops. Multiply by this value. Okay, so it will be -2, -3, -4 over 6. Then this one will be -27 over 64 t cube. T cube is not needed. Okay. So just like that. So just multiply everything, simplify it. At the end, your answer will be 37 over 256. Make sure the positive negative sign is correct. Over here is a positive sign. So that will be the answer for the probability for x equal to 4. Okay. So now we move on. That will be question number 5. Okay, now we take a look at question number 5. Two companies P and Q produce a certain type of paintbrush and independent examiners rates the quality of the brushes produced as poor, satisfactory, or good. He takes a random sample of brushes from each company. The examiner's ratings are summarized in the table. So these are the information given. Test at 5% significant level whether the quality of the brushes is independent of company. Okay, so this one is a chi-square test. So what you need to do now is for this, usually I will just withdraw again the table, but I need to add up the total. Okay, so this one I need to add up the total and write it the value beside a little bit so that I can put in the expected frequency. So this one is a 64 and 31. I get this one as a 95. Then you total the row. You get this one as a 125. You get this one as a 75. Then the total together is 200. So now we want to find the expected frequency. I will put the expected frequency in the bracket here. And to find the expected frequency, what I need to do is I just need to take these two values, multiply together and divided by 200, I get 25 for the first column, first element. And after that, I take this, multiply, add together, divided by 200. Then I get this one as a 15. But actually, just take these two add together must also equal to the 40. Yeah. Okay, so actually there's no need for me to be so troublesome. But however, just for you to aware of lah. Okay, so here to save time, I calculated the expected frequency already. Both of them add together must be 65. So this one is a 59.375. This one is a 35.625. Okay, so these are the table that we have. Now we are ready to do the hypothesis test. So the null hypothesis is that we just copy down the sentence here. The quality of brushes is independent of company. Then versus the quality of brushes is not independent of company. Okay. So this is the hypothesis. Then your significant level is 5%. And find the degree of freedom. So the degree of freedom, you have the 2 row multiplied by 3 column minus 1. 2 row minus 1, 3 row, 3 column minus 1. So multiply them together, you have 2. So from here, you can get your critical value with the degree of freedom of 2. And your confidence level is 95%. Check the formula table. You get this as a 5.991. Okay, now we want to go for the test statistics. So the test statistics, it will be chi-square without any remark. So the formula for chi-square is OI minus the EI square over the EI. Just do one by one. In exam, the mark scheme expecting us to show the value one by one. So I will go by row. Okay, I will go by row. Okay, I'll just go by row here, row by row. Calculate the value row by row. So the first row, 1.96 plus the 0.1388 plus the 0.3603. 3603. This is the first row. And the second row will be 3.2667 plus the 0.2314 plus the 0.6004. Add together, you can get the test statistics as 6.56. Three significant figure. So from here, you can see that your test statistics chi-square is actually greater than your critical value, chi-square of degree of freedom 2 and 0.95. So for this case, you reject H now. So now your conclusion is reject H now. That means there is sufficient evidence to support that the quality of brushes is not independent. Company. So that will be the answer for the question number 5A. Okay, 5A. So we still have five part B. Okay, part B is over here. Compare the quality of the brushes produced by the two companies. So the companies have two companies only, P and Q. So we need to find the, that means we need to compare. This is representing the data for the P, company P. This one is the company Q. Okay, so we need to add them up to compare and give some comment. Okay. Okay. So what you need to do is we need to find the chi-square for the company P and the chi-square for the company Q. So the chi-square for the company P is you total them up, you get the chi-square P. Total them up over here, you get a chi-square Q. Okay. So if you total them up for the company P, you get this as a 2.4591. And if you compare the Q, you get this one as a 4.0985. Okay, and your who is bigger? Which one is bigger? Your company Q is bigger. So the bigger the chi-square value is, that means the more inconsistent it will be. So that means the one that is lesser the chi-square, that means it's more consistent. That means the quality will be better. Okay, so because of this reason, so therefore, company P produces better quality of brushes than company Q. Okay, so this will be the answer for the number 5, part B. Okay, so now we move on to the question number 6. Okay, now we take a look at question number 6. Jade is a swimming instructor at a sport college. She claims that as a result of an intensive training course, the mean time taken by students to swim 50 meters has reduced by more than 1 second. She chooses a random sample of 10 students. The times taken in seconds before and after the training course are recorded in the table. So that means the training time has improved more than 1 second. So we can decide either the before, we consider this one before as a B, after as a A. So we want the B minus A to be more than 1. Should be before, because before the time will be longer, right? So we want the B before minus A, B minus A more than 1. Okay, so over here, since I have the space over here, I just need to extend my table to one more row to save time. Let's extend it. I just want to find the difference. The difference is a B minus a A. Okay, so just extend this table, one more row, then just press a calculator. You get this one as 4.1, 1.1, negative 0.4, 0.2, 3.9, 2.6, negative 0.6, 3.5, 0.1, and the 0. So now we are ready to do the test statistics, to find the, to do the hypothesis test. But before that, we need to find the sum of the D and the sum of the D square. So the sum of the D, to save time, I have calculated it earlier. Sum of the D is a 14.5. Sum of the D square, it will be 52.81. Okay, from here, we need to find the mean, the so-called bar D, and we need to find the unbiased estimations of the population variance. It will be 1 over n minus 1, the sum of the x square, minus the sum of the x square divided by the n. Press the calculator, you'll get the answer as 3.532. Okay, so these are the information that we need to do the hypothesis test. So we need to build the null hypothesis and the alternative hypothesis. So we just say that the mu B minus the mu A is equal to 1, or the mu B minus the mu A is greater than 1. This is a right tail test. The significant level alpha is a 1%, 10%, so 0.1. Your critical value, this one, it will be T distributions. T of the degree of freedom is 9. Your confidence level is 0.9. Then you'll get this one as a 1.383 from the formula table. Then your test statistics, the T will be using the formulas of the D. The D is the bar D, sorry, not the D, the bar D, minus the mu A, mu B minus the mu A, divided by the square root of the S square divided by the N. So the bar D is a 1.45. Mu B minus mu A is a 1. S square just now we found is a 3.532 divided by 10. Press the calculator, you'll get the answer as 0.757. This is your test statistics. And if you compare the test statistics, compare with the critical value, I will modulus both sides. Less than, so over here you accept H now. So your conclusion is, there is, now when you accept H now, your conclusion will be there is insufficient evidence. To support that. Mu B minus a mu A greater than 1. Okay, or you can say that insufficient evidence to support the swimming instructor claims, or the Jade's swimming instructor, the name is Jade. So you can just say that insufficient evidence to support Jade's claim. That's all. So this is the answer for the question number 6A. Now we move on. We have a 6B. State an assumption that is necessary for the test to be valid. So for this case, usually we need to assume that the population difference is normal distributed. Okay, so we just say that the assumption is the population distribution, the population differences. Why we say population differences? Because we are taking the two different two data minus together. Okay, before and after we minus it together. So that is the meaning of population differences. Is normally distributed. So this will be the answer for the number 6B. Okay, moving on. Question number 7. Okay, now we take a look at question number 7. The continuous random variable x has a probability density function. This is a density function. F given by following here. Find the variance of the square root of x. So for this case, we need to do a lot of things over here. So first of all, we need to find the e square root of x. E square root of x is you just integrate from 0 to 2, multiply the square root x with the fx. Okay, so if you multiply everyone here with the square root of x, that will be 0 to, you will have x power 3 over 2 over 4 multiply 4 minus the x squared. That will give you x power 3 over 2 minus the 1 over 4 x power of 7 over 2. Integrate it, 2 over 5 of x power 3 over 2, 5 over 2. Minus the 2 over 9. Okay, so it's a 1 over 18, x power 9 over 2. Substitute 2 and 0, 0 and 2 inside. Substitute 0 and 2 inside, 2 and 0 inside. Put it in, then you get this one as the 2 over 5, 2 power 5 over 2, minus a 1 over 18, 2 power 9 over 2, minus a 0. Simplify it. So over here, we can get the answer as 32 sub 2 over 45. You can give the answer in decimal if you want to, because the question didn't mention of any value. They didn't mention exact value or decimal, so we can just write like this. Now we want to find the e square root of x squared. So that will be the same as the ex. So this will be the same as the 0 to 2 of the x squared over 4. Then you multiply them. Integrate x squared minus the 1 over 4 of x power 4. You get x cubed over 3 minus the x power 5 over 20 from 0 to 2. So you get the answer. You get this one as an 8 over 3 minus a 32 over 20 minus a 0. Press a calculator and you will get this one as the 16 over 15. We prefer exact value. At least I prefer exact value, so I will avoid using decimal place over here. Now the variance of x, variance of square root x is actually ex. To be more precise, supposed to be ex squared like this, minus the e square root x squared. So it will be 16 over 15 minus the 32 2 over 45 square. And if you press the calculator, so this value, I think maybe we can just direct press it. The question didn't require us to give the answer in specifically any form. So we just leave the answer in decimal. Fraction also can, no problem. So I just give you the answer as decimal, 0.0553. So this is the answer for the part A. A bit long for 4 marks, but I don't think we have any shortcut on that. So just move on. Part B. Now the continuous random variable y is divided by y equals to the x squared. Find the PDF for the y. PDF, they are not looking for the PDF, probability density function. Okay, so we know that the gy will be the probability of the y less than or equal to y. So since the y is an x squared, they tell you that the y is an x squared. That means this x will be less than or equal to the square root y. We only consider the positive square root y. We will not consider the square root negative y. So this will be the same as a g square root of f. It's f. Okay. So in order to find this, we need to find this. So we need to find the cumulative function. We need to find the cumulative function, CDF, cumulative function. So okay, so this one, I need to spend some space over here to find the CDF for this one. I need to find the CDF for this one. Okay. So your fx is integrate from 0 to x of what is the function here? This one I expand directly. I get an x minus a 1 over 4 x cubed. X minus a 1 over 4 x cubed. Integrate, I get x squared over 2 minus the x power 4 over 16 from 0 to x. So at the end, I get this one as the x squared over 2 minus the x power 4 over 16. Okay. So still extend a little bit. So therefore, my CDF is 0 for x less than 0, 1 for x greater than 2. Then this one, it will be anything in between, 0 to 2. Will be like this. Oops, not enough place. My apologies on that. I expect it to be this way. Zero, x squared over 2 minus the x power 4 over 16, 1. This one is x less than 0. This one is a 0 to 2. This one is x greater than 2. So this is the CDF. So from here, you just need to change the x here becomes square root y. Just change the x here becomes square root y. Then this one, it will be 0 for the square root y less than 0. This one will be the square root y square. You get a y over 2 minus a y square over 16 for this. This is a 1 for the y square root y greater than 2. So therefore, your gy is 0 y over 2 minus a y square over 16. Y less than 0. Y is between 0 to 4. And the y is greater than 4. But they want the PDF, not the CDF. So we need to differentiate. Differentiate, then you will get this one as the differentiate the middle one, it will be half minus the y over 8 for the y from 0 to 4. The rest are 0. Done. This will be the answer for the question B. Now we move on. Question C. Find the exact value of the median. Exact value of the median. So exact value of the median, just take the CDF of the G. We want to find the median. We let the median as M. Then it will give you a half. So from here, from this one, we just need to put M over 2 minus the M square over 16 is equal to half. Multiply everyone by 16, you get 8m minus the m square equals to the 8. So you have a m square minus the 8m plus 8 equal to 0. They want exact value, so we don't use, we just use the quadratic formula to find the m. So it will be negative b plus minus of b square minus of 4ac divided by 2a. So at the end, your m is equal to 4 plus minus of 2 is 2. So therefore, your m is equal to the 4 minus the 2 is 2, because your m is between 0 and 4. Okay, because your m is between 0 and 4. So that will be the answer for the question C. And moving on or no more. Okay, so this will be the last question for this paper. And I'll stop the video here. I'll see you next time. Bye-bye.